Hello viewers, welcome to my channel and thank you for watching the videos and subscribing the channel and for registering the course also. इस वीडियो में न्यूमेरिकल एनालिसिस का 7th लेक्चर आइलर्स मेथड, रुंगे कुट्टा मेथड ऑफ सेकंड ऑर्डर एंड फोर्थ ऑर्डर फॉर सॉल्विंग ऑर्डिनरी डिफरेंशियल इक्वेशंस को डिस्कस किया जाएगा। तो आइए देखते हैं। Hello viewers, in this video I would like to discuss numerical solutions of ODE. So what is an ODE? An ordinary differential equation is a relation between a function, its derivatives. Say y is equal to fx's function, so derivative will be y dash, y double dash, etc. and the variable upon which they depend. So y is depending on x, y is equal to fx, so x is the independent variable. There is only one independent variable in an ODE. So mathematically we can write it in this form. General form of ODE is phi xy y dash y double dash y to the power m is equal to 0. It means x is independent variable, y is a function which depends on x, and y dash y double dash etc. these are its derivatives, and m is the highest order derivative here, and these are the functions of x, y, and its derivatives are functions of x. Now this is an example. The law governing the velocity vt of a moving body is given by m dv upon dt is equal to f. So this is an equation, and another example is equation to describe a simple harmonic motion is given by m d square y upon dt square plus a dy upon dt plus ky is equal to 0, where y is displacement and m is the mass. Now these equations may be solved. Hello viewers, in this video I would like to discuss numerical solutions of ODE. So what is an ODE? An ordinary differential equation is a relation between a function, its derivatives. Say y is equal to fx's function, so derivative will be y dash, y double dash, etc. and the variable upon which they depend. So y is depending on x, y is equal to fx, so x is the independent variable. There is only one independent variable in an ODE. So mathematically we can write it in this form. General form of ODE is phi xy y dash y double dash y to the power m is equal to 0. It means x is independent variable, y is a function which depends on x, and y dash y double dash etc. these are its derivatives, and m is the highest order derivative here, and these are the functions of x, y, and its derivatives are functions of x. Now this is an example. The law governing the velocity vt of a moving body is given by m dv upon dt is equal to f. So this is an equation, and another example is the equation to describe a simple harmonic motion is given by m d square y upon dt square plus a dy upon dt plus ky is equal to 0. In this video I would like to discuss numerical solutions of ODE. So what is an ODE? An ordinary differential equation is a relation between a function, its derivatives. Say y is equal to fx's function, so derivative will be y dash, y double dash, etc. and the variable upon which they depend. So y is depending on x, y is equal to fx, so x is the independent variable. There is only one independent variable in an ODE. So mathematically we can write it in this form. General form of ODE is phi xy y dash y double dash y to the power m is equal to 0. It means x is independent variable, y is a function which depends on x, and y dash, y double dash, etc. these are its derivatives, and m is the highest order derivative here, and these are the functions of x, y, and its derivatives are functions of x. Now this is an example. The law governing the velocity vt of a moving body is given by m dv upon dt is equal to f. So this is an equation, and another example is the equation to describe a simple harmonic motion is given by m d square y upon dt square plus a dy upon dt plus ky is equal to 0, where y is displacement and m is the mass. Now these equations may be solved by analytical methods and numerical methods. So when we don't find easily analytical method or problem is very complicated, we try numerical methods. So while there are many general techniques for analytically solving classes of ODEs, the only practical solution technique for complicated equations is numerical methods. So there are two types of problems: initial value problem and boundary value problems. So initial value problem is when conditions are prescribed for one point only, then differential equation is known as initial value problem. Example is here, y dash is equal to minus 2x minus y, and y at 0, that is x is equal to 0, value of y is minus 1. So this is initial value problem. And boundary value problem is when the conditions at different values of independent variable are specified. It means we have at least 2 points where value of y is given. Example is here, y double dash is equal to 6x plus 4, and y at 0 is equal to 2, y at x is equal to 1 is 5. So this is boundary value problem. As we know, there are many numerical methods to solve the ODEs. In this video I would like to discuss Euler's method. So what is an objective of Euler's method? That we have to find out solution of ordinary differential equation, that is dy upon dx is equal to fxy, and initial condition is given to us y at x0 is equal to y0. So what will we do? We will find successive values of y, and then these are the approximate values. So we find successively y1, y2, yn, where yn is the value of y corresponding to x is equal to xn, and xn is equal to x0 plus nh, and takes values y2, 3 and so on, and h being small value. So in this figure we can see this is the curve given to us, and we start with the value x0. This is the x0. This value is x0, and corresponding value is this is y0. Now we have divided this interval into n number of points. So this is x0, x1 is equal to x0 plus h, x2 is x0 plus 2h, and last point is xn, which is x0 plus nh, and corresponding values are y0, y1, y2, y3 and so on, and this is yn, and this is the actual values of y on this point xn. So here we can see this is the error in the value which has been approximated, and the actual value lies on the curve, and approximated we have obtained with the help of Euler's method. So this is the error in the result. Now we take the now the equation of tangent at x0, y0 is y minus y0 is equal to dy upon dx at x0, y0, x minus x0. So from here we can write down value of y, and at x is equal to x1, value of y1 is equal to y0 plus x minus x0 is h, because now x is x1, so x1 minus x0 is equal to h, and fx0 y0. Now similarly we can write down in the next interval, that is x1 x2, so we will get value of y2 will be y1 plus h fx1 y1, and in general form we can write down yn plus 1 is equal to yn plus h fxn yn. This formula can be derived with the help of geometrical interpretation also, that we can write down tan theta form, and from there we can also derive this. Now let's see one example based on it. Using Euler's method, solve numerically the equation y dash is equal to x plus y. Initial value is given, y0 is equal to 1, and we have to calculate values of y for x is equal to 0, and increment is of 0.2, and we have to go up to 0.8. So points will be 0, 0.2, 0.4, 0.6 and 0.8. Check your answer with exact solutions, because this is very simple equation, so we can find out exact solution also. So let's see. y1 is equal to y0 plus h fx0 y0. fx0 y0 means value of the function at x0 y0. So y0 is initial value, which is given 1, plus h is given 0.2, that is the difference between two consecutive values of x, so that is 0.2, and y dash, which is fx0 y0, is x0 plus y0, that is given in the question. So we put x0 value, which is 0, and y0 value is 1, so y1 comes 1.2. Now we calculate y2. So 1.2 plus h is 0.2, fx1 now it is 0.2, plus y1 is 1.2, we get 1.48. Now y3 is y2 plus h fx2 y2. y2 is 1.48, h is 0.2, and fx2 y2 is x2 plus y2, so value of y3 comes 1.856. Now in similar manner we calculate y4, and value comes 2.3472. Now we see exact solution is 2e to the power x minus 1. We substitute values of x as 0, 0.2, 0.4, 0.6 and 0.8, and compare the exact value and Euler's value. We can see there is a small difference. For 0.2 it is exact value is 1.2428 and Euler's value is 1.2, and similarly for 0.8 exact value is 2.6511 and Euler's value is 2.3472. So we got the result with the help of Euler's method. Thank you. Hello viewers, in this video I would like to discuss modified Euler's method. So in modified Euler's method we take average of the slopes at the beginning and end of the interval to compute yn plus 1. So formula is yn plus 1 is equal to yn plus h yn dash plus yn plus 1 dash by 2. We substitute values of yn dash and yn plus 1 dash. So it comes yn plus h fxn yn plus f xn plus 1 yn plus 1 by 2. So we say this is improved estimate of y at xn plus 1, and the value of yn plus 1 inside the function, in the second function you can see here where fxn plus 1 yn plus 1. So here we predict it by using the Euler's formula, that is yn plus 1 is equal to yn plus h fxn yn. So we can substitute this value here and write the formula again. So we can write yn plus 1 is equal to yn plus h. First term is fxn yn, same as it is, and in the second term we write Euler's formula. So fxn plus 1, this is same, comma, in place of yn plus 1 we write Euler's formula, and that is yn plus h fxn yn, and of course brackets are closed by 2. So our objective is to find out solution of ODE, that is initial value problem. So dy upon dx is equal to fxy, y at x0 is equal to y0. This we have to find out, and we know the formula for 2 points, that is x0 y0 and x1 y1 can be written as y1 is equal to y0 plus h by 2 fx0 y0 plus fx1 y1, and general form can be written as yn plus 1 is equal to yn plus h fxn yn plus fxn plus 1 yn plus 1 by 2. So let's see one example. Using modified Euler's method, find y at x is equal to 0.1 and x is equal to 0.2, given that dy upon dx is equal to y minus 2x upon y at 0 is equal to 1. So we will directly use the formula which we discussed in previous slide, and we put values here. So 2 points, when we take 0, n is equal to 0 and plus 1 is 1, so we can write down values here. y0 is given to us, that is 1, and h is 0.1. fx0 y0 we can calculate, and in the second term y1 we have to calculate with the help of Euler's formula. So we are writing here Euler's formula to calculate y1. So y1 is equal to y0, which is 1, plus h is 0.1, fx0 y0 we will put here in dy upon dx, y0 minus 2x0 upon y0. So x0 is 0, so the only thing is y0, which is 1, so here we put 1, so y1 comes with the Euler method as 1.1. We take this y1 to calculate this y1, so we now substitute in the average formula. So 1 plus h is 0.1, f0 1, that is fx0 y0, we know x0 is 0, y0 is 1, plus f x1 is 0.1, which is given to us, and y1 we have calculated with the help of Euler's formula, that is 1.1 by 2. We will put these points 0, 1 and 0.1 and 1.1 in the dy over dx equation, and we will find out the values of the function here, and then can calculate the values. So we see f 0.1 1.1 is equal to this much, 0.9182, and the previous term, the first term we have already calculated, which comes as 1. So we take the average and calculate the value of y1, which is 1.0959. so at x is equal to 1, at so now we write them in a tabular form. X is 0, 0.1, 0.2, and Euler's values we have calculated as at 0.1, 1.1. At 0 it was given, that was initial value, which was given 1, and at 0.1 we have calculated 1.1. At 0.2 we have calculated 1.1918, and when we applied modified Euler's formula we got 1.0959 for x is equal to 0.1, and for x is equal to 0.2 we got 1.1841. Thank you. हेलो व्यूअर्स, वेलकम टू माय चैनल। इस वीडियो में हम रुंगे कुट्टा मेथड सेकंड ऑर्डर एंड फोर्थ ऑर्डर करेंगे। जैसा कि आप जानते हैं न्यूमेरिकल टेक्निक है टू सॉल्व ऑर्डिनरी डिफरेंशियल इक्वेशंस। रुंगे कुट्टा मेथड्स एग्री विद टेलर सीरीज सॉल्यूशंस अप टू द टर्म HR, where R refers from the method to method and is known as the order of that method. So अगर R is equal to 2 है तो सेकेंड ऑर्डर रुंगे कुट्टा मेथड हो जाएगा। अगर R is 4 then it is रुंगे कुट्टा मेथड of fourth order. रुंगे कुट्टा मेथड of second order is the modified Euler's method. तो अब हम Euler modified method का फॉर्मूला देखते हैं, which is y1 is equal to y0 plus h by 2 fx0 y0 plus fx1 y1e. ये क्या है, हमने स्लोप्स का एवरेज लिया, because this is 1/2 and these are the summation of these two terms which are slopes. जहाँ की y1e की वैल्यू हम आइलर मेथड से ऑब्टेन करते हैं, और क्योंकि ये नोन वैल्यू है और आइलर मेथड से ऑब्टेन हुई है, सो वी आर राइटिंग इट y1e. y1 इज स्टिल अननोन, ये अभी हमें सॉल्व करना है या ऑब्टेन करना है. अब हम y1e की वैल्यू फॉर्मूला है जो कि ये 1 है, इसमें सब्सटीट्यूट कर देते हैं. सो y1 इज इक्वल टू y0 प्लस h बाई 2. फर्स्ट टर्म एज इट इज है fx0 y0 प्लस सेकेंड टर्म में x1 को हमने रखा x0 प्लस h. सो f ऑफ x0 प्लस h, और सेकेंड इसमें एलिमेंट है y1e, तो ये हमने आइलर फॉर्मूला से y1e की वैल्यू सब्सटीट्यूट कर दी जो यहाँ पर हमने डिपिक्ट की थी, y0 प्लस एच एफ x0 y0. अब हम टेलर सीरीज को यूज करते हैं. हम जानते हैं y1 जो है y x0 प्लस h है, इसे टेलर सीरीज से एक्सपेंड कर सकते हैं. y0 प्लस h y डैश 0 प्लस h स्क्वायर अपॉन फैक्टोरियल 2 y0 डबल डैश एंड सो ऑन. सो y1 इज दिस विच वी हैव रिटन इन प्रीवियस स्लाइड. इसमें ये जो सेकेंड टर्म है ये फंक्शन ऑफ 2 वेरिएबल्स है, और इसे हम टेलर सीरीज से एक्सपेंड करेंगे. सो एक्सपेंडिंग दिस बाय टेलर सीरीज फॉर ए फंक्शन ऑफ 2 वेरिएबल्स. तो अगर हम ये टर्म यूज करें विच इज दिस टर्म, सेकेंड टर्म इन y1 इज इक्वल टू fx0 y0 प्लस h del f अपॉन del x x0 y0 प्लस h f0 del f अपॉन del y x0 y0 प्लस ऑर्डर ऑफ h स्क्वायर. एंड अदर टर्म्स भी आएंगी, हायर ऑर्डर टर्म्स, उन्हें हम निग्लेक्ट कर देते हैं. सो ये हमने ऑर्डर ऑफ h स्क्वायर में क्लब कर लिया. सो नाउ वी राइट y1 अगेन विच इज हेयर. y1 is y0 plus h by 2 f0. The first term is this, is we are denoting by f0, plus here in second term expansion we get this term as f0, so this term is f0 plus h del f upon del x x0 y0 plus h f0 del f upon del y x0 y0 plus order of h square and higher order terms. Now we know df upon dx is equal to del f upon del x plus f del f upon del y. तो ये जो टर्म है हम इस फॉर्म को यूज करते हुए लिख सकते हैं that y1 is equal to now y0 as it is plus h, ये twice of f0 हो गया, एंड ये 2 कैंसिल हो गया. सो f0 प्लस h, एक h ये है एक h ये है, सो h स्क्वायर अपॉन 2, दिस 2 इज हेयर, एंड दिस रेस्ट ऑफ द टर्म इज अकॉर्डिंग टू दिस एक्सप्रेशन गिव्स अस f dash 0 प्लस ऑर्डर ऑफ h क्यूब. And y1 is equal to y0 plus h y0 dash plus h square by 2 y0 double dash, because we know f0 is y0 dash and f0 dash is y0 double dash plus order of h cube. Order of h cube we have taken, you can see here very clearly that this was h term and next term is h square, and here this now term is h square and Euler's method will be h cube. Taylor series solution up to the term in h square. Therefore the improved Euler's method is the Runge Kutta method of second order, and this is the formula which we have used. So here we make some assumptions to simplify this formula, that we write first term, that is h fx0 y0 as k1, and the second term as k2, that is h fx0 plus h. This term h is outside, fx0 plus h y0, and this term is k1, so y0 plus k1. Now we can write down y1 as half of k1 plus k2, just to simplify the above formula. This is basically Runge Kutta method of second order. So when we write y1, which is the next predicted value, is equal to y0 plus k. Now we see Runge Kutta method of fourth order. तो यहाँ पर हम k1 पूरा डेरिवेशन नहीं कर रहे हैं, k1 वैसे ही है जैसे सेकेंड ऑर्डर में था. k2 की वैल्यू बदल जाएगी, एच एफ एक्स जीरो प्लस एच बाई टू वाई जीरो प्लस k1 बाई टू. k3 is this much, एच एफ एक्स जीरो प्लस एच बाई टू वाई जीरो प्लस k2 बाई टू. k4 is एच एफ एक्स जीरो प्लस एच वाई जीरो प्लस k3. तो आप इन्हें याद करेंगे बिकॉज दिस इज very much necessary. You need not to derive at that time. K is this much, and y1 is y0 plus k, and x1 is x0 plus h. एग्जाम्पल देखते हैं. compute y.2 given dy upon dx plus y plus xy square is equal to 0, y0 is equal to 1 by taking h is equal to 0.1 using RK method of fourth order correct to 4 decimal places. So y dash dy upon dx is basically y dash. ये दो टर्म जो हैं हम राइट हैंड साइड पर ले गए, सो माइनस एक्स वाई स्क्वायर प्लस वाई. k1 इज एच एफ एक्स जीरो वाई जीरो. k2 की वैल्यू ये होगी, तो इसमें वैल्यू सब्सटीट्यूट कर दी. h जो है 0.1 गिवन वैल्यू है, एंड x0 y0 इज इक्वल टू 1 गिव्स x0. ये वैल्यू x0 है विच इज इक्वल टू 0, और y0 वैल्यू 1 है. ये वैल्यू y0 है जो कि 1 के बराबर है. ये वैल्यू सब्सटीट्यूट की k1 में, सो 0.1, एंड एफ एक्स ज़ीरो वाई ज़ीरो का मीनिंग है कि y डैश में हम x की जगह x0, y की जगह y0 सब्सटीट्यूट कर दें, तो जो वैल्यू आएगी वो वैल्यू यहाँ पर होगी. दैट इज़ x0 तो 0 है, तो फर्स्ट टर्म 0 हो गई, और प्लस y0 ये 1 हो गया. आउटसाइड माइनस है, सो -1, एंड प्रोडक्ट इज 0.1 इंटू -1 इज -0.1. k2 निकाल लेते हैं, इसकी वैल्यू ऑब्टेन कर लेते हैं. h 0.1 है, फंक्शन की वैल्यू 0.05 0.95 पर निकालना है. इसका मतलब x की जगह हम 0.05 सब्सटीट्यूट करेंगे और y की जगह हम 0.95 सब्सटीट्यूट करेंगे. तो यहाँ से जो वैल्यू आएगी वो वैल्यू हमारी k2 की वैल्यू होगी. ये बेसिकली हमें कहाँ से वैल्यू मिली, 0.05 एंड 0.95. ये वैल्यू मिली x0 विच इज़ 0 प्लस h इज़ 0.1 by 2. So this gives 0.05, and y0 is 1 plus k1 is minus 0.1, so minus 0.1 by 2. So 1 minus 0.05 is equal to 0.95. तो ये वैल्यूज़ जो हमारी फंक्शन जिन पॉइंट्स पर है, ये वैल्यूज़ इससे ऑब्टेन हो गई. k2 की वैल्यू माइनस 0.0995 ऑब्टेन हो गया. k3 फाइंड आउट करते हैं. सो k3 इज़ this formula. Again h is 0.1, x0 is 0, h is 0.1 by 2, so first term will be same 0.1 f 0.05, second term will be y0 is 1 plus k2 is this value अपॉन 2. तो ये जब सॉल्व करेंगे दिस कम्स 0.95025. फंक्शन की वैल्यू, इसकी वैल्यू यहाँ निकाली तो दिस इज द वैल्यू. मीन्स फंक्शन में हमने x की जगह 0.05, y की जगह ये सब्सटीट्यूट किया और ये फंक्शन है -x y² प्लस y. वैल्यू k3 की ये आ गई. नाउ k4 इज h fx0 प्लस h प्लस y0 प्लस k3. सब वैल्यूज अवेलेबल हैं. h इज 0.1, x0 इज 0, h इज 0.1, y0 इज 1 प्लस k3 ये वैल्यू है. तो ये सारी वैल्यूज निकाल करके हमारी वैल्यू आती है 0.1 f ऑफ 0.1 एंड 0.9005. तो ये वैल्यूज अगर हमने फंक्शन में रखी 0.1 एंड 0.9005, k4 की ये वैल्यू. Once we get all the values of k1, k2, k3, k4, we substitute those values in the formula of k and can find out k value. So first iterative value we got y1, which is y0 plus k, and then we can find out second iteration after repeating all the steps, which is better than the previous formula. So y2 is 0.8046. Thank you for watching the video.